Dear State Secretary, ICES scientists and delegates, ladies and gentlemen, it's a great pleasure and honor for me to be able to stand here before you and talk about aquaculture. I was asked by our research director a while back ago, he said, would you give a talk, could I suggest you for giving a talk to ICES about aquaculture? And I said, sure, of course. And I didn't realize what talk he was talking about, which I found out earlier this year when I was going to prepare a little bit in advance. Let me see. So I have this fairly pompous title, which I have to say I actually made up myself, so I can't really complain. When I started to make the talk, there's some difficult words there, but I'll try to lead you through this. I started my working relationship with the Institute of Marine Research in 1987 on domestication of marine species, halibut and cod, in our research station in Austevoll, just south of Bergen. Then I was asked in 1990 if I wanted to go into salmon lice, because I had a background in chemistry, and we wanted to look at alternative treatments. I'm the only person in the world who actually wears a salmon louse on myself. It's made of silver, presented to me when I did my doctor's thesis, and it's sort of, I find salmon lice fascinating. My first breach with ICES was in 1994. I attended a meeting in St. John's in Newfoundland. When I was thinking back, I think I remember more of jungle gyms in the high street, actually, than the conference. But I have attended ICES over the years, and in 2002, I met my husband in Copenhagen on the ICES conference. For the last 6 years, I've been working as the head of aquaculture in the Institute of Marine Research, and we have been challenged then with not only doing research, but also do advice. And this is also why I then chose both research and advice in this topic. This is one of the central slides that we like to show when we talk in Institute of Marine Research, to focusing on the importance of research for better management advice. As you and ICES probably know better than me, I'll try to point with this. All the Norwegian seas, like the Barents Sea, the Norwegian Sea, the North Sea, and the Skagerrak, have a long story of research and advice. But I'm very happy this slide has just recently, or over the last few years, been updated. So it actually also includes that we are supposed to do advice in aquaculture. The outline of the talk, I'd like to say a little bit about aquaculture. And just to clear up a little bit about the wording, the working group that I'm in now is environmental interactions of mariculture. In Norway, we don't do this distinction between aquaculture and mariculture, but aquaculture traditionally also embodies the freshwater, brackish water, and marine waters aquaculture. Then I'd like to say a little bit about sustainable development, going through to some of the research that has been done around the world, and say a few words about advice, which is not always easy. FAO is always a good source for statistics in aquaculture, as well as other species or other areas. This is a figure from the 2010. They are a little bit behind with some of the statistics, obviously, for obvious reasons. And the trend, as we see, is that the world capture fisheries and aquaculture production is not the same. Where the fisheries have sort of leveled out when it comes to the tonnage that's taken ashore, the aquaculture production is increasing. And increasing to a degree where it starts, at least in Norway, to actually have a higher income nationally than the traditional fisheries has. I was told beforehand that I shouldn't be talking too fast, and I shouldn't run ahead of my notes now so that I get everything in here. So I'll try to do that. If we divide this up by continents, what you also see is a trend is it's the really huge production of aquaculture happens in Asia. The lilac-y color here is the Americas, both north and south. And Europe, as you can see, is not really a very large producer when it comes to value even. but the tons are probably higher in Asia. Just to breach a little bit on salmon aquaculture, because salmon is what we do in Norway. What we see here is I've taken out the countries that produce salmon. The red bars is the Norwegian production, and what is typical for this is that it's constantly increasing. We have about a production in 2012 that sort of hits about 1 million metric tons. The other high producer was, or is, Chile. What is special about the Chile situation is that, let's see, oh shit, sorry. I'm trying to use the pointer because if I use a laser pen, you won't see it on both screens. What happened in Chile was that they had a decline. Decline brought on by probably poor management, disease dispersal, local sea lice that they have, and they really didn't have the system to cope with our very high production. They were up to almost 400,000 metric tons, and it fell very rapidly. The other thing that you can take home from this one is that the other producing countries like Ireland, United Kingdom usually meaning Scotland, and Canada has over the last 10 years have a sort of steady production, not growing. In 2009, this slide was made and sort of predicted something for the future. We see the same leveling out of the capture here, and when it comes to aquaculture, this is limited to fish, crustacean, and mollusks, meaning it's not including plants in this example, and it's a global aquaculture production, including the ICES. If you prognosis that there's going to be a 3% yearly growth, we'll hit 90 million tons in 2027 was the prediction from 2009. The increase for the world capture has been around 1.2% over the last 30 years, while the aquaculture actually has increased by 9% over each annually. And if we go on to the newer numbers, for 2010 it was up to 60 million already, meaning a value of 120 billion US dollars. So this is a huge field. If you go down to the countries, we see here that on the bottom graph, using this mouse for pointing isn't very easy. Oh, there we go. With the red and orange colors, meaning more than 30 million tons, and the orange from 1 to 5 million tons, these countries are all in Asia. You see, China is the main producer when it comes to biomass, and this is aquatic animals for human consumption. But we also can notice that when it comes to the countries around the Atlantic, that Norway, France, Spain, and the US, Chile, it's not in the Atlantic Ocean, but Brazil is also fairly high producers when it comes to animals for human consumption. The reason for China being so totally dominating as well is that they use production in all trophic levels, meaning that they have all the way from the plants upwards doing a total production of a lot of species. There's another map that I like, which confused, when I had a little trial, actually confused the audience. This is a way of visualizing the production by letting each country's surface area represent the amount of tons that are being produced. So I don't know if you recognize. I wonder if I actually should have a pointer. You recognize the, that's not working very well, is it? Europe at the top not being a very high producer. I think this kind of map is very strange. I think if Columbus had used it, it might have even reached India, or at least China, probably. But it at least shows how the world is doing today. I also think it's very important to point out the technical development that happened in aquaculture. This is a very early picture from 1983 of King Harald of Norway being out looking at this new and wonderful fairy tale of aquaculture. This is now a research station in Austevoll. I want you to notice the wooden planks. I think he must have been wet at his legs here. The further development's gone on to here, where we still have wooden planks somewhere. We starting to go into steel. Usually the feed for the fish would be wheelbarrowed down onto the cages and thrown into the cages. And precision throwing of fish pellets was a very high-end pastime for some of these people. Going on all the way up to this. This is a farm in Norway. What you can see here is that you have what we call the polar circles lying individually in the sea. This can only be reached by boats. You all have to have farm boats. And one person asked me what this is. And technically it's a raft. It's also where the feed is kept. There's probably millions of tons or tons and tons of feed in there, which is pumped out to each individual cage through a hydraulic system. And these cages are starting to get very large. This is a visualization that is stolen from Aqualine, who is a producer of some of these cages, showing that when the diameter of these rings increase, the visual of the cages decreases, and to the largest cages today, you actually only can see 0.2% of the cage where you have fish. These cages are typically from 30 to 50 meters deep, which gives some food for thought when people want to bring it on land. The area there might be a little bit difficult to handle. So what sort of signified this development has been the material used. There's been a huge feed development issues, feed distribution, but we still have some problems, of course, with other sides of it. There's increasingly a lot of reports today that you do analysis of ways to produce food. This is one report from the Blue Frontiers, Managing the Environmental Cost of Aquaculture. They've done very thorough research into what they call life cycle analysis of a lot of different species around the world, in Asia and other places. It takes on the inputs of doing the fish farming and the outputs, and do analysis of this regarding eutrophication, acidification, climate change, which is important, the energy demands, the land occupation, thinking of bringing things on land, and the biotic depletion as such. And what their conclusion was is that if you're going to produce livestock, you should do well to look into aquaculture to actually produce this, and that should be very seriously considered. Because when the resources are stretched, the benefits of aquaculture exceeds other livestock production. We come to sustainable development. Sustainable is a very difficult word, and we had a discussion earlier today about the possible new expert group in aquaculture, and what do people mean when we say sustainable? Food production is never without impacts, and sometimes when you talk to the wider public, you get an impression that by sustainable means untouched. And that's a very difficult concept to get to grips with. You get the impression that they would love to have a wheat field, but they also want to pick the blueberries from the forest that used to be there. And that's not very easy. So I was looking into also other words when used when it comes to describing sustainable. Ecological footprint is the usual way of talking about these impacts. I've included a picture here. Not all footprints are very light. This is a 2 million year old footprint. So a footprint can last for a long time. When it comes to the ecological footprint, it usually means that you do a measure of how the human demand on the Earth's ecosystems and the amount of biologically productive land and sea area that is necessary to sustain the population, and how much you have to use to actually assimilate the waste that you go in with. If you use this system, it's possible to estimate how much of the Earth, or actually in some instances how many Earths you need to support humanity and at a given lifestyle. And if you, for instance, do this for suggesting that everybody was going to live by a Western standard, the Earth can have 4.5 billion people. So that's also food for thought. Sustainable development, the World Commission on Environment and Development, also called the Brundtland Commission, had this definition, what they meant by sustainable development. And it says sustainable development is development that meets the needs of the present without compromising the ability of future generations to meet their own needs. This tells me that we are looking for something that is not irreversible. It's a very important word. But this doesn't tell us how to do it. So that's the big issue. When it comes to sustainable, to me it means a responsible management of the resources that we need to produce. It also describes how the biological systems can remain diverse and productive and very important over time. And it's a very necessary precondition for well-being of humans and other organisms to have this sustainable or responsible management. But you also have to remember that it's several dimensions to this. You both have the environmental dimension, you have the economic dimension, and the social dimension. And when it comes to these dimensions, some people might think that these are all playing in together and each are given equal weight, which is not always the case. Very often the economic dimension of a production takes precedence over the social or the environmental. Somebody suggested that these, the figure on the right, we should swip them around and have the environmental as the center of dimension when it comes to sustainability. So there are some challenges that comes out of this concept of sustainable food production. And one that I think is very important is that you have to ask yourself, is this thing that we're doing now making irreversible effects on the ecosystem? And this goes for both land and sea. And will the production bring unjustified use of non-renewable resources? Of course, unjustified is also a difficult concept to answer. And then again, if the use of the resources is acceptable. And this also comes back to that we all stakeholders and political governments have to say something about what we think is acceptable. When it comes to aquaculture research, like I've been working on sea lice for 20 years. The thing that brought me, I know that garlic doesn't work for treatments. It's nice in food, but it doesn't work. I usually include the picture to the left to annoy my ICES colleagues, because when it comes to aquaculture and inshore and even shoreline research, you don't really need geosars into the shoreline. And people who like to be on big boats sort of find it annoying when I show this picture of a very small dinghy. We use much larger boats, and this is a picture of myself looking for sea lice. So I had to include a picture where I do my own research, even though it's a little bit a while ago. When it comes to the aquaculture research, it has a very broad focus. We just returned from Prague, where the Aqua 2012 was held. Every 3 years, they have a combination of the World Aquaculture Society and the European Aquaculture Society. So this is a really huge conference, and 11 parallel sessions over 4 days, 10 to 15 different topics every day. This time it was 496 posters. You have to be very specific in your search when you are going to see that much. But the focus range is also very wide. A lot of the talks are on different species for aquaculture. There is talks about politics and legislation, environmental interactions, which I attended during this conference, animal health and welfare, and technology development, to mention a few. And this tells us that there's a lot of research being done. There's still a lot of potential, I think, for pulling this research together and coming into the advice section. I've included this picture. It's a very European-dominated slide. Very typically Atlantic salmon and cod. You have the sea bream and sea bass. There's more for the southern countries. Halibut is there. There's oysters and scallops. What is extremely missing is plants. Macro and microalgae are not in this picture. And I think that is going to be important to address trophic levels as we move along in aquaculture development. The other thing about this one is that when we picture climate change and try to look forward what will happen with aquaculture, we've already seen that like the southern part of Norway isn't that suitable really for Atlantic salmon. So the whole structure of the species that you want to culture can be heavily affected by climate change. Not only in Norway, obviously, maybe more so further south. The possible impacts you can have from an open cage aquaculture is more or less the same all around and for every species. Not totally the same, but I tried here and I used the word impacts, not interaction. So this is the impacts that comes out of a fish cage. What is very typically being addressed for quite a while is the exceed feed and feces that might fall to the bottom under cages. Myself, I've been working with a disease and disease dispersal, like the parasite sea lice, who disperses widely in the environment. Other virus and bacteria as well. You have the possibility for escapees, and you have also associated outputs, medicine, pharmaceuticals of any kind, and treatments that can come out of a sea cage. There's even been added noise, odor, and visual impacts at the top of the slides, and this is some of the problems that you can have with the general public when it comes to impacts from aquaculture. To narrow it down a little bit, I'd like to address some examples what have been done in Canada, Scotland, and Norway. These are all countries that have produced Atlantic salmon. For Canada, then on both coasts, for Scotland and Norway, obviously in their waters. They have done things on the strategic framework of their aquaculture, and there are some key themes, and I'd like to look a little bit on what's different and what's the same. There's also a lot of indicators under development. If you want to measure an impact, you have to have a very clear view on what you're going to measure. So you need an indicator that you believe actually tells you something about the impact as such. And then the next important step is the thresholds or the acceptance criteria that are under discussion in all countries now, and where you move into the political territories. What are we willing to accept when it comes to effects from aquaculture? Scotland gave out this report in 2009, what they call the renewed strategic framework for Scottish aquaculture. They had themes, key themes that they found important. From my point of view, I immediately saw the healthy, efficient shellfish, the improved containment, pointing to the SKPs. So there are several of the important things in the legislation also addressed in this report. When it comes to Canada, this report is from 2012. It's more a report on aquaculture sustainability, and they also have several key themes that they want to address. And you recognize again the health and the protective ecosystems that they want to look at, ensuring resources used efficiently, and also the ensuring of safe and healthy products that they have found important. In Norway, also in 2009, there was a strategic document, Strategy for an Environmentally Sustainable Norwegian Aquaculture Industry, which focuses on some of the same topics. We also highlighted the SKPs, the disease, here also area management and pollution. So we see that all these countries, all these 3 countries that produce the same fish more or less comes up with the same issues that they want to address when in the strategic framework. So there are some common problems on the open sea cage farming. I wonder if I could have some water, please. I think it's very important, the disease transfer, in particular parasites and virus. Of course, I put that on top since salmon louse is a parasite. This is in context to effects on wild populations. The same with the genetic impact that SKPs can entail. Eutrophication problems, both local and regional, is very important. And the possibility for organic overload, both local and regional, in any given area. The release of therapeutics and toxins, like in Norway where we have to treat for sea lice, you obviously have a release of therapeutics. When I saw the balcony here, I was wondering if I actually should have taken sort of a stand-up approach to, but then I didn't get a free or a microphone, so I'll drop that. Sorry. I've seen too much live at the Apollo. Okay. The impact of behavior of fish can also actually affect how things happen, and the feed intake of wild organisms. In Norway, we actually started to see now that we have to have a look not only at the bottom, but also the pelagic fishes around fish farms that might change their behavior when it comes to all this feed that is so readily available to them. And use of area management is a topic here for the ICES, so I haven't really gone too much into that. And the legislation and management is also very important. This is how we sort of approach this in the Institute of Marine Research in the program that I'm heading on research and advice, that we have these 4 key topics with environmental and ecological effects, both to aquaculture and ocean ranging. We're looking at health and disease dispersal and the interactions between farmed and wild fish populations, and the effect of SKPs, mainly on salmonid and cod. The cod being more difficult, of course, because they also spawn in the net pens. The picture to the right there in the brownish color is a salmon louse. You have to come over afterwards and see if you can see that it is the same thing I have here. Just to be very brief, there's 2 sessions in this ICES conference, both the P session and the Q session, addressing both sustainable aquaculture development and a lot of other interesting talks. So I won't really go into any of the results that we have, But I really want to point out that for the Norwegian situation, we found in our risk assessment that the effects of wild salmonids, when it comes to the effect on wild salmonids, it's the salmon louse and the SKPs that is a threat. We've analyzed it to find it to be a very high probability of an impact. Whether or not it is population regulating still remains to be seen. We have, there's talks being made during these days on the suggestion we have for first generation indicators for these two impacts. And we have suggested some thresholds that can be used. This is now up for political decision. And I think that it will be something coming out of Parliament early next year on some of these issues. I'm not sure what the Sjømatmelding is in English, but we might find out. These two pictures that I included is, of course, salmon to the left. And to the right, we have a part of the Norwegian fjord, including where we sit now in Bergen, pointing towards that we want to use models, hydrodynamic and biological models, to predict dispersal, in this instance, of sea lice larvae. When it comes to defining the effects of or impacts around the farm, in Norway we have a system called the MOM that sort of defines how you're supposed to monitor around the farm. This has found its form in a national standard, 9410, that says how you should monitor effects within what is called here the side zone. We also have what we have chosen to call a transition zone. There is a zone from the farm and out where you might or might not have impact, and then you come out to a certain boundary where you will have the remote or the regional effects. There we have the EU's water frame directive coming into play now that says something about how things should be monitored. This can be a little bit difficult to fit into some of the more fish farm related problems, because the water frame directive hasn't really enclosed into it such a thing as aquaculture. It's more sort of waste from land and definition of the coastline in different water bodies. And aquaculture, we are struggling a little bit to fit it into this system. But I have an example after this one. I just wanted to show you some pictures of the sea floor. This is a special cage structure who is moving around. It only has one point of connection. So it's over a larger area, and you can see underneath farms sometimes that you could get a very high production of other animals, wild animals. Here you can see a prawn, some sea urchins, and polychaetes production, and 1.5 kilometers from the farm, there's not really that much there. So there's somebody who said that we should start thinking of extracting this biomass instead of trying to dilute the effluents from the fish farm. But this one, when you want to examine effects of aquaculture, it's very important to develop, and recently we started to use ROVs for these surveys. This is remotely operated vehicles and also diving. These pictures are taken from the Hardanger Fjord. You can see a fish farm more up close with the polar circles. And what we do is take transects all the way from the shoreline, from 0 meters and into the deep. And you do a total classification of the species that you find, both of algae and animals. In this instance, mostly the algae. Use the algae as an indicator, and as you go further and further down into the sea, the macroalgae will yield, and you can find other organisms, and like here at the bottom, sea urchins, for instance. When we use this system in the Hardanger Fjord to assess areas very close to a farm and places away from a farm. We came up with this using the water frame directive methods for associating effect. The EQR is the environmental quality ratio, meaning that you have a value for untouched areas and a value for what you perceive as exposed areas. And I must say, to somebody's surprise, that in all of Hardangerfjord, where you have a production of 50,000 tons of salmon, the EQR values show the score of good to very good water quality and situation of the macroalgae. Another word that's often used when it comes to aquaculture and the release of materials is carrying capacity. It was also mentioned today in our meeting in the possibly new expert group on aquaculture. Carrying capacity has a very wide definition, and the ICES study group already in 1987 made a statement on what they thought carrying capacity was. And as you can see from this, they define it in relative to available food resources, so in a wild context. Another word is the holding capacity, that's defined as when it's limited by a non-trophic resource, also the environmental interaction of mariculture group. But I find that the assimilative capacity word, the ability of an area to maintain a healthy environment and accommodate waste, is a very good word, assimilative capacity instead of carrying capacity. Although we still call it carrying capacity. And I would like to take you through this slide. When you have a production or a biomass, some of your impacts will be related to the actual biomass. For instance, SKPs is not technically totally related to biomass, but the more fish you have, you could say that the more fish stir, the larger the risk of actually having SKPs. But for a lot of the impacts, the impact is related to the total biomass produced. So for any given impact, you will have a definition on how much it impacts. And another impact might have a totally different range or a slope to the curve here. And then it comes in that you do need to have an environmental standard for each of these impacts, both for the 1 and for 2. Let's say that the number 1 is the sea lice and the number 2 is the organic waste. It then falls into this slide that the carrying capacity for the 1 is much lower than the carrying capacity for the second. And from this, you have to conclude that when you look at all the impacts, it's the impact that gives the actually lowest carrying capacity that is the one you have to adhere to. Because you can't really use the one or the other. You have to go for the one that gives the lowest impact. The environmental standard is where the politicians come into view, because the standards will say something about what we are willing to accept in the environment. I also wanted to say a little bit of risk assessment, which has been a topic for some of the meetings I've been within the ICES, and the area management that we use in an ecosystem-based regulation. And it has been addressed before here today that it's very important to have a holistic and an ecological-based planning for regulation of the marine environment. And this is very old news for you in the ICES. But for the aquaculture impacts, it's very important to protect the biodiversity and to maximize the profits from the resources that you actually use. And the area management plans will be very important for the framework for other regulations as well. I like the ecosystem approach. The EAA is the ecosystem approach for aquaculture. And it sort of entails that you have to examine the existing and developing aquaculture and identify the key priority issues for management, and so that you can have a sustainable outcome and within a risk-based management framework. And I think that's very important to do this in a risk-based and very scientifically sound basis. There's a lot of reports coming out now that methods for risk assessment of aquaculture, that none of them are very much in agreement, but there are a range of criteria that has been proposed. And when you have an impact, it's very important to sort of find the nature of this impact. Is it positive, negative, direct, indirect, the magnitude, of course, the extent or the location, like is it area, volume demanding, is it the distribution, local, regional, and the duration? Are you in the startup of a production, or are you in decommission? Is it production or as usual? The reversibility is also important, and the likelihood of something. What is the uncertainties of these impacts, or the confidence intervals of the predictions that we make? And there's several methods that is for the predictions that are suggested. At least I know that I, as a scientist, will prefer it to be a quantitative mathematical model. And when we started to try and do the risk assessments for the Norwegian aquaculture industry, we just had to say we don't have enough data for doing that. So we had a combination of case studies and both experimental and physical models, and some professional judgment had to come into play. This is going to be a talk as well, so I won't go into our risk assessment in very much detail. But deciding the indicators is very important for the impact. The practicability, is it available? Is it really measurable? And especially, is it accurate? And what kind of coverage can we hope to get? And then we come to the thresholds again, the acceptance criteria, and this is more like where the risk-based analysis comes in. What are we willing to risk when it comes to this impact? And the challenge then, of course, is supposed to group together the multiple impacts you have and the possible regional effects as well. We have a new risk assessment coming out in January. The old one is available for those who want to see it, so I won't say more about that, but please go and hear the talk. So the gaps we have in our knowledge and assessment is effects on hard bottom organisms has come up. Also the impact of nearby algae has been addressed. And recently a lot of questions have been raised about sensitive organisms, sponges, corals, and other sensitive habitats as well. And then to monitoring these regional effects is very important, and as I already said, how do we calibrate this, for our instance, with the EU Water Frame Directive? The Norwegian conclusions when it came to the research that we have done and the surveillance that have been done is that it is the salmon lice on sea trout and the genetic impact of SKPs, salmon, that is the most problematic factors in the Norwegian waters. The resistance towards chemical treatments for sea lice, where we can't use garlic, is also important. And the risk of regional eutrophication and negative organic load is actually very low in Norwegian waters, which I think came as a surprise to a few people. I see a lot of possibilities for cooperation here, and the need to develop a cross-sectoral common understanding and handling of these environmental risk assessments is, for me, very important. And to find these methods of assessing the impacts and the vulnerabilities, and also try to strive towards national and international standards, like the ISO is one example here. And if we could at all come up with the common indicators and thresholds to use for our monitoring, this would be great. This is an example of a new ISO standard that's just out. It's monitoring of the impacts from marine finchfish on soft bottoms. And I don't know what you think when you hear soft bottoms, but this is on the seafloor. If you snigger when I come to the hard bottoms, I don't know what I'll do. But this is a totally new standard, ISO 12878, just out, I'm recently also working with ICES standard together with colleagues on the sea lice monitoring, and we'll convene in Reykjavik in October. So I think this is good work. And I also find that the possibilities for aquaculture in ICES is very exciting. I was told that I had to spell out the acronyms because some of our very renowned ICES people in the Institute didn't know what IME was. It's the Environmental Interactions of Mariculture. And also the Marine Shellfish Culture had a joint meeting in Sopot this year. And we're in discussion whether there should be an expert group now on written sustainability in aquaculture. And during these discussions today, we sort of found out that we had some problems actually using the word sustainability and what people would think this was. But as a first step, I think that Norway especially needs to have some of our national reports peer reviewed by the international community and hopefully maybe ICES when it comes to this. And now I come to the advice. I haven't written good advice, not excellent advice. We'll have to start with advice. And it's not very good, it's not easy to give advice. Like my father says, it's difficult to predict, especially about the future. So advice can be difficult to give. I know one very good advice, a Norwegian advice, is to always wear wool closest to your body. But this is like, we go into the world as a Norwegian, you say this and say, oh yes, they know what they're talking about. It's a cold country, yes, we believe this. This is probably good advice. So good, we have maybe 8,000 years of knowledge on this. It's almost genetic. So this is one advice you can give easily, but how to give good advice is difficult. And I find it very difficult going into the world and give advice on aquaculture because there's something about the perception. We very often are met with that we have a conflict of interest, and I think we've been bought by anyone, if it's the Ministry of Fisheries or the fish farmers. When we give an advice, we're not always believed, and I found someone to blame. It's Hollywood. This is a picture, so I don't know if it's Pixar or it's Disney. I don't know if you have small children, you would recognize little Nemo in the middle there, who's a clownfish who's lost and lives on this very happy little reef. It's very colorful. And I think that a lot of people in this world believes all of the ocean to be such. So the perception of people of what the ocean is lacking. And I have a little film. My colleague has provided me with this snapshot of some of the findings from the northern Norway. I can't look at this because I get seasick. It's a reason for me choosing aquaculture instead of fisheries. So I only do the inner fjords. The sea bottom, hard bottoms. No sniggering, very good. There's mountain ranges. Here we see a wolffish on the sandy bottom. There's a few microalgae here. There will be a monkfish coming into view. There's shell sand in this instance. So all of this is taken from the northern part of Norway, from Nordland and Troms, and it's a part of our assessing sea bottom habitats for along the coast. Here we see macroalgae and some bentos, and a little bit of marine snow actually coming into play here. There's mixed bottom, stone, sand, algae, and a halibut coming in. I think we're going to also see some kelp forests, not so deep this take. But I also find interesting when we come now to the marine snow. I think if somebody said to you, oh, this is a picture from next to our aquaculture farm, people say, oh, yes, we can see that. But it's actually very, very natural. Let's see if they go. Here we go. This is how it can look as well. The marine snow, the settlement of organic and inorganic material on the bottom. Mapping what we have and what is there is very important. And this is a soft bottom. with basket stars and soft corals, starfish, and some anemones to the bottom. And none of them looks very much like the Nemo picture. That doesn't mean that there's a full play to go out and do havoc on this, but you could visualize that there are places and there are sea bottoms that wouldn't be such a big risk to expose to some aquaculture. Good. So what we know is that fish farming is mainly today done in open cage system, and many interactions are possible. And all the methods and criteria that are available today for assessing risks is getting into place, but setting the acceptance criteria again, and the judgment on the impact is something up for both political decision makers and stakeholders, I think is very important. And it should come as no surprise to people who have been in ICES for a long time. Also in aquaculture, we see the need for extensive monitoring programs to document and quantify these impacts that we see. And there is a limited range of data, risk factors, and the basic knowledge, and again, the monitoring programs is very important. So we need baseline data on natural conditions, surveillance programs, a lot more on cause and effect, and the thresholds. And most importantly, if we do hit a threshold, what do we do? What do we do to reduce the effect? I just wanted to end with some views for the future. We've seen today that it's important, in my view, to have a look at the production in several trophic levels. IMTA has been mentioned earlier today. It's the integrated multitrophic aquaculture, and also ocean ranging. I've stolen this from Fredrik Hauge in Bellona. It's in Norwegian terms, very famous NGO. Here he has made a picture of the ocean forest project, where you see the possible windmills and fairly large aquaculture production ranging from microalgae or macroalgae up to fish around. When you use the area for windmills, why don't you also use it for aquaculture? And a small sketch here of how you can visualize the integrated multitrophic aquaculture. It's also possible to see that you could use the CO2 and the wastewater that we have to produce macro and microalgae, and actually using this in different ways. You will have lipids and high value substances. You can have carbohydrates to put in your car. You can also have the protein to grow more fish. And I was recently introduced to something called biochar, which is when you burn the rest, you end up with a substance that stores carbon and can be used as a soil improvement. So this is a sort of win-win situation. Another example is that if you wanted to use hybrids for biofuel, if you wanted to do that on land, you need about the area of Europe to produce enough fuel for the airplane travel that we do in Europe. And then the example was that if you use macroalgae, you only need the area of Belgium. And in that context, somebody was willing to sacrifice Belgium. It's also important that the governance, this is taken from an FAO report, and how to achieve then the global aquaculture sector's long-term goals. And I strongly believe as well that to commit to provide and support a good governance framework is very important. So I believe science, like it was said earlier today, we do need a solid scientific documentation, and we need peer-reviewed international publications that hold up even in court. And good advice. It's very important, I think, that we have a transparent process and that we continue to strive towards an international consensus on what these issues are. And that's where I hope that both we in Norway and other countries can rely on ICES to bring us forward. Thank you.